see, we know the final Cooper-Jacob equation. When we calculate the Thais equation, that is complicated, that 0 minus 0.5771 equation is there, na? That we will solve. Then we got this final equation, S equal to 2.303 Q upon 4 pi capital T multiplied by log 2.25 capital T upon r square S plus 2.303 Q upon 4 pi capital T into log small t. Okay, this is the our final equation. So if we see carefully this equation, we can see that this is a kind of straight line equation, that is y equal to mx plus c or c plus mx, whatever. So you can, if we put s as y and log t as x, then this parameter will be our m, that is slope, and this whole parameter will be our c, that is intercept. Okay, so if we plot in a graph that is of s and log t, drawdown, that is in arithmetic scale, and our time in a logarithmic scale, okay, then we found this straight line. Okay, you can see from here to here. Okay, so this distance will be our intercept, that is equal to this value. Okay, and this slope, whatever the slope value m, will be of this value. Okay, so now if we want to, we have to find two things. Okay, one is transmissivity and another is storage coefficient from this equation. We can find it from Thais equation also, but it is more simpler. That's why Cooper and Jacob simultaneously bring this equation, okay, and this graph to calculate the transmissivity and storage coefficient properly and easily. Okay, so what can we do? We know one thing, that slope is always equal to y2 minus y1 upon x2 minus x1. So we can write it as, if our x1 is this and x2 is this, x1 is this, x2 is this, y1 is this, and y2 is this. Okay, so we can put the values s100 minus s10 equal to log 100 minus log 10. We know log 100 equal to 2 and log 10 is 1. 2 minus 1 is 1, and this parameter we can write as del s. So our slope will be equal to del s only. Okay, but we know through the equation that our slope is equal to this value, so we can equate both the values, del s and this value, and then it will be equal to del s equal to 2.303 q upon 4 pi t. Okay, from graph, if you take a one log cycle means in a graph, if there is 0.1 10 1, then 10, then 100, so this is one log cycle, this is one log cycle, this is one log cycle. Okay, if we take this, then this is a 2 log cycle, and if we take both of this, then this is a 3 log cycle. Okay, one log cycle means whenever we divided the consecutive terms, like if we divide this and this 100 by 10, we are getting 10 as value, and the log of them is 1. Okay, so then it is considered as one log cycle. Okay, because log 100 minus log 10 is equal to 1. So we have to consider one log cycle from the graph. Okay, suppose 10 and 100. So whatever value of we will get in the drawdown, we have to take the difference of date, that then we will get the value of del s. Okay, the q will be given in the in the question only. Okay, then you can put the q and del s in this value. 4 pi 2.303 are constant, and you get the value of transmissivity. Okay, now we have to calculate the storage coefficient. Now I have to find the storativity. Okay, so for that we know this equation, already discussed in the first time at the first of the video. Okay, so this equation we can write as, it is in the form of log a plus log b, so we can write this as log ab in this way. Okay, so we know that 2.303 q upon 4 pi t, both is common here, so we can write this as common. Okay, then it will become log 2.25 capital T upon r square s plus log small t, that we can write it as in the multiplication format. Okay, then it will be, this is a and this is b, so a into b. Okay, because here it is log a plus log b, na, that's why. Okay, so completely it will become del s equal to 2.303 q upon 4 pi t into log of 2.25 capital T small t upon r square s. Okay, here this small s is drawdown. Okay, drawdown, and this is storage. coefficient. Okay, don't confuse with this term, that's why I write in a different way both the s. Now we know that at t naught means at the initial when the just the pumping started, then we know that when just the pumping started at that time there will be no drawdown. So you can see in the graph also, if it touches to t equal to 0, then the s becomes means a t equal to something, we don't know the t naught value here now, right now. So we know that del s becomes 0 here. Okay, so we at t equal to t naught, del s equal to 0. If this will become 0, then we can, then if we cross multiply this constant term, then it will also become 0, and the final will be log 2.25 capital T t naught upon r square s equal to 0. Here we write the t naught. Why? Because del s is considering 0 at t at time t naught, that's why. Okay, and we know that 0 is actually what, log 1. Okay, we know not 10 raised to the power 0 equal to 1, that's why. So log both the term is there, we can remove it and it will become 2.25 capital T naught upon r square s equal to 1. We can cross multiply this, but we want the value of storage now, then we will make the storativity as our principal value, and it will become s equal to 2.25 capital T naught upon r square. Okay, r will be given in the question. Okay, t you had already determined. Okay, here you will get the value of capital T. Now you want the value of t naught. Okay, so in the graph, suppose I'm telling you here only, suppose this is our semi-logarithmic graph, you get this straight line here. So what you did, you just extrapolate this line, and wherever this straight line will meet in the x-axis, that will be our t naught. Why t naught? Because you see that our s becomes 0 here. We know that at time t naught, drawdown is equal to 0, there is no drawdown. So whatever t naught value you will get, you will put here. Okay, and then you can easily calculate the value of s, capital S, that is storage coefficient. In this way you have to calculate the value using graph and Cooper-Jacob equation. You have to remember these two formulas, this one and this one, and you have to draw the graph using the value of drawdown and time in a semi-logarithmic graph, where x-axis will be our time in a logarithmic scale and y-axis will be drawdown in arithmetic scale, and whatever straight line you will get, you have to extrapolate. You will get t naught by one logarithmic cycle, you will get the value of del s. You have to just put the value q and r, discharge and distance will be given in the question. You can easily find out the transmissivity and storage coefficient.